Yeah, okay. So this slide shows you, anyway, this is not my slide. This is actually taken from a university abroad and then in a temperate country. So that's why you can see them wearing large jackets. And this slide shows you what are the devices used in marine water sampling. Now, you're going to see that some of these devices, they are very similar than what we have learned before in the surface water sampling, except that I think I probably did not show you a few that is used for sediment. Now remember earlier when I teaches you soil sampling, there are uh, some device to sample sediment. Yeah, that is related. That is actually part of the marine sampling, because in marine science, it's not just water. You also have to take the sediment, because in the sediment you are going to analyze what are the life forms inside, the chemical composition, and so on. So I think this way we only going to look at the water phase only. Yeah. Okay. So these guys will going to sit on a boat, and in some cases lah, when you want to sample marine water, it's either you sit on a big boat or a small boat. Most of the case, you're going to sit on a bigger boat, not this small. This is to me like a sampan. No, not enough lah. Yeah. Now at times when you want to sample surface water, also sometimes you need to rent a boat or a sampan, because what? It depends on what you want. If you want to go at the center of the lake, or you want to go to the center of a river which is very deep, you cannot fly over, so you have to sit on a sampan lah. So far, I haven't heard any water sampling directly from a helicopter, but I know that is possible. But it is not being done at the moment lah, simply because helicopter are going to disturb the water flow. So usually we use sampan lah. Yeah. Okay. So when you're at the location, how you're going to take the, oh, this one is the Eckert sampler. If you still remember the video by UMT, if you still remember that video that I asked you to refer to, they are using this, the Eckert sample. Now this one is a sample sediment, so not related, I'll skip. Now this one is, it's called Nansen bottle, but there's a better version of this bottle. We call Niskin bottle. Nansen bottle and Niskin bottle, they are very similar, except that you say that Niskin is better because they open at both ways. Nansen, they open at one part of this bottle. So what is done here is you're going to lower this bottle, and then it actually lowered vertically, not horizontally. There's one similar bottle that is lowered horizontally. And if you still remember, it's called camera bottle, if I'm not mistaken. If not mistaken, it's called camera bottle. So it is lowered, and then you have a messenger sent to it. It will going to close it. So when you lower this bottle, it is open so that water can fill in until it reaches at the bottom. So when the messenger goes in, messenger is actually like a heavy object. When you drop it, it will going to knock the closing mechanism and it will close the tip. So after that, you bring it up. Okay. And then after, once you bring it up, you release this messenger, open the top, and then pour the water into a sampling bottle. That's it. Move on to the next sampling point. Okay? By the way, in most of these Nansen bottle, they're not just going to collect water. At the same time, they're going to be equipped with a thermometer. So you can see it's a thermometer. So by the time you pull it up, first thing that you do is you read the temperature, because temperature will change very fast when it comes to the surface. So first thing that they do is they're going to read the temperature to reflect the temperature where this marine water is collected. Then after that, they pour the content. So they get two datas lah. And then this is the advanced version of the Nansen bottle, the Niskin bottle. Look very similar, except that, you see, they open at two ends. Okay? So when open at two ends, that means the water, when it flows through, will not going to have turbulence. Because if you open at one end, the water will going to flow at one direction. So there will be turbulence, and turbulence actually is a source of contamination. Because by the time it reaches the bottom, turbulence might going to agitate the sediment, and that might going to add some more sediment into your marine water lah. So by hitting this one, it will going to prevent agitation, turbulence is not there, and then slowly it comes down. It's more reflective of the groundwater that you sample at a certain trophic. Because you know lah, if marine water is very deep, they may have regions that they have different temperature and different water characteristic. So if you can open two ends and when you can lower down very slowly, it's virtually going through this trophic and doesn't have any physical interruption. So there's no agitation. So it is better in a way that it does not mix the marine water that much and it does not interrupt the integrity of the sample. But it works more or less the same way. You have thermometer, it will close when you send messenger, it closes at both ends and it works the same way actually. Now, I think you probably have heard this device before, Secchi DIS. Now, Secchi DIS, most of the time for marine scientists, they are going to bring it along just to monitor the visibility or the what you call visible permeability of the water bodies. Now, this Secchi DIS is like a circle. It's a disc. It's a circle, and most of the time it is divided by 4 regions. Two of the regions is white in color, the other 2 regions is black. So how are you going to do it? Of course, it is tied together with a very long rope. What you will need to do is you lower from the top very slowly until you cannot differentiate black and white. Because why? At a certain depth, it will going to darken and you're going to like darken the white region. So once you discover the point you cannot differentiate white and black, you stop and then you measure the depth. So this depth is what they call the Secchi depth, in which that is a depth where you cannot see through, where the light cannot pass through and you cannot see the white color and you cannot differentiate white and black. Why do we want to determine this one? Well, this is like from the past characterization in which people want to want to know how deep is the light permeability. That is more towards biological study and ecology. But in terms of turbidity studies, you probably don't make too much of difference because in turbidity, we probably most of the time we use SI unit. We use SI unit, how many grams of suspended solid. So this is related closely to suspended solid, in which it's more applicable to ecology and marine studies. Okay, temperature, I think I'll skip this one. Put thermometer and then measure, as easy as that. And plankton toll. Now, this is not to sample water, but more of to sample the waterborne organism inside. So once they tow this one and then they put it in a sample bottle, they use microscope and see what kind of strange creatures that are catching. Well, that is part of the marine science. And in fact, I just recently, a few months ago, went to a lab, analysis lab, in which they mentioned that brackish water and also marine water, the standard for these two water bodies is much more higher and more stringent than surface water. Let's say, for example, if you say like the permissible level of mercury inland for fresh water, if you compare to marine water, they are like at least 10 times, if not mistaken, 10 times or 100 times, much lower than the one inland for fresh water. Imagine that. So that's the level that they put up for marine water. So don't be mistaken, no. The one that you have in your lab report, in your lab manual for water resource technology, that is for surface water for the environment. However, for marine, it's a different set of standard. It's not the same, just for your information. And with that, that is all what I want to tell you.